This is the disc pump control app when you first launch it. The first thing you will need to do is connect your PC to the development kit. To do this, you will need to select the communication port or COM port that is communicating with the development board. First, click on the drop-down arrow shown here. You may see a number of COM ports listed. The easiest way to identify the correct COM port is just unplug the USB cable going to the kit and then plug it back in again, and then you will see the port added to the list. In this case, it was COM port 5. Click on COM port 5 and then hit the connect button, and then in a few seconds you will see the system inputs spring into life. Looking at the system inputs, one to note here is the pressure sensor reading as shown. When you have nothing connected to the pressure sensor, it is always worth clicking on the 0 button as shown, which will then calibrate the sensor for use. This is now reading 0 and ready to be used. The next thing you may want to do is open up a plot window so you can see what is happening. To do this, click on the small plus sign as shown here and a plot window will appear. In this, you can plot various values for either single or multiple pumps, and you can also drag these windows out onto separate screens, but I will touch on this later. For more information on how to use this feature, please consult the user manual. For the purpose of this demonstration, I will be using the default settings, these being power and pressure, and these can be plotted on different y-axes as shown, and this just makes it easier to see what is happening. You can change the axis by checking the box as shown. You can also change the scale of the plot by using the central scroll button on your mouse. You can also drag the plot and move it up and down using the mouse as well. And this is quite a useful feature should you need to see something that is on a different scale. Having set up the plots, it is now time to look at the different system control methods, the first of which is direct power control. As mentioned earlier in the video, the default setting here is through the dial or potentiometer on the development kit board. Therefore, as you turn the dial up and down, you will see the dial value changing, and this is corresponding to an input power to the pump between 0 and 1000 milliwatts. The greater the power applied to the pump, the greater the performance. If I then enable the pump by clicking the pump enable button, you'll see that as I turn the dial up, the pressure increases. When I turn the dial down, the pressure decreases. Having seen direct power control through the dial, if you now click on this drop-down box, you will notice there are several other options. To learn how to use these, please again consult with the user manual. There is, however, one I would quickly like to touch on, and that is manual control. By selecting manual control here, the figure that is in this manual box, so 650 milliwatts, will be applied to the pump when you click the pump enable button. I click pump enable, drag that down so you can see it, and you can see 650 milliwatts being applied to the pump. If I say then want to reduce the power applied to the pump to 233 and hit return, you'll see the power drop to 233 milliwatts. It's very quick and easy to control the pump through this method. The second system control method you could look at is PID control, which automatically tracks to a given target. By selecting PID control, you will note that there are a range of set points and a range of inputs, so please consult with the user manual before proceeding. In this example, we are going to use a manual set point, i.e. what is typed in this box here, so 200 millibars, and the input from the digital pressure sensor that is on the development kit board, as we have the pump connected to that. Therefore, when I connect to the pump by clicking the pump enable button, the pump power will be adjusted so that pump pressure exactly hits 200 millibars. I click pump enable. You can see the power to the pump in blue being adjusted to exactly hold 200 millibars. The pump is extremely accurate. The important thing to note here is that you will have to tune the values of P, I and D for your individual system. For more information on how to do this, we have a separate video that goes into this in more detail, so please see the link below. Another area of PID control I would like to touch on is where you use the dial as the set point value. This is a great example showing the speed of response of disc pump, because what we're going to do here is adjust the dial value and see disc pump match that exactly. The important thing to note here is we will be following both a positive and negative pressure gradient. Therefore, we will need to use the Lee orifice mentioned earlier in the video and set that up as shown in the schematic coming up on the screen now. Inserting the orifice in this way enables the head pressure to bleed out around the pump, because the valves in the pump will hold a degree of pressure. Another thing to note here is if you do need to hold pressure in the system once the pump is powered down, the Lee company also offer a great range of non-return valves. So in this example, we have a dial, And the dial value, as you can see, is set to around 74. So when I enable the pump, you can see the pressure rise and the pressure equaling the dial value. Now, when I adjust the dial, you can see that the pressure follows the dial value almost exactly. A great example of the speed of response of this pump. The final system control method you could look at is bang-bang control, which turns the pump on and then off when it reaches the relevant threshold values. Think of it a bit like a thermostat in your house that controls the heating. When it's too cold, the heating comes on, and then when it gets too hot, the heating goes off, and it cycles between the lower and upper threshold on a continual basis. In this example, we will again be following a varying pressure profile, where the pressure needs to increase and then decrease, and for this you will need to use the Lee orifice to bleed back the pressure in the system. The schematic is on the screen now showing how this needs to be set up. To demonstrate this bleed back principle, in this first example there is no orifice fitted, so when I enable the pump, you can see how the pressure quickly builds but then decays very slowly because it's bleeding back through the valves in the pump. If you need to then make sure that the pressure bleeds back more rapidly, you introduce the orifice and you can see that the pressure builds and then decays very rapidly. This is particularly important in applications like pressure-driven flow, where you need to stop fluids moving very, very quickly. Finally, I would like to draw your attention to the power limit box, the unit drop-down boxes, and the logging box. The power limit box enables you to drive the pump to its highest rating, which is 1400 milliwatts. As this is recommended for intermittent use only, there is a second safety checkbox to prevent pump damage. The unit drop-down boxes are pretty self-explanatory. These enable you to choose a unit of measurement that you're more familiar with. And finally, we have the logging features. This is really useful as it logs all settings, values and results during testing so that you can review these later. This is very useful if you observe something and need to study it in more detail. It is also good for system diagnostics should that be needed. You can log information for a single pump or for all pumps by clicking on the All tab.